The sun, our life-giving star, has been shining brightly in our sky for over 4.6 billion years. But have you ever wondered what the future holds for our sun? Will it one day turn into a black hole, or will it meet a different fate? Join us as we explore the life cycle of our sun and its ultimate fate in the vast cosmos. Let's start at the beginning. Our sun was born from a giant molecular cloud composed of gas and dust in a process that took millions of years. Gravity pulled this material together, forming a protostar that eventually ignited nuclear fusion in its core. This fusion process converted hydrogen into helium, and our sun was born. A yellow dwarf star, the main sequence star that has provided light and warmth to our solar system ever since. Over billions of years, the sun has remained stable, supporting life on Earth and driving the climate and weather patterns we experience today. Currently, our sun is in the main sequence phase of its life cycle, a stage that will last for about 10 billion years. During this phase, the sun maintains a stable state by converting hydrogen into helium through nuclear fusion. This process balances the inward gravitational pull with the outward pressure from the fusion reactions, keeping the sun in a state of equilibrium. However, this balance won't last forever. Eventually, the sun will exhaust its hydrogen fuel. When this happens, the sun will enter the next phase of its life, expanding into a red giant and undergoing dramatic changes. The core will contract while the outer layers expand, leading to a significant increase in the sun's size and luminosity. This transformation will mark the end of the sun's main sequence phase and the beginning of its red giant phase. As the sun ages, it will eventually exhaust its hydrogen fuel in the core. When that happens, the core will contract under gravity, causing the outer layers to expand and cool. The sun will transform into a red giant, swelling to a size that may even engulf Mercury, Venus, and potentially Earth. This phase will mark a dramatic change in the sun's life, as it will become much larger and cooler on the surface, but intensely hotter at its core. Eventually, the sun will shed its outer layers, leaving behind a hot core that will cool and shrink into a white dwarf, marking the end of its red giant phase. After the red giant phase, the sun will begin fusing helium into heavier elements like carbon and oxygen in its core. This period of helium fusion will be relatively brief compared to the main sequence phase, lasting only a few million years. Eventually, the sun will shed its outer layers, creating a spectacular planetary nebula that will illuminate the surrounding space with vibrant colors. What remains of the sun will be a hot core, a white dwarf approximately the size of Earth, but incredibly dense, marking the final chapter of its evolution. This white dwarf will slowly cool and fade over billions of years. So will our sun ever become a black hole? The answer is no. To become a black hole, a star must have a mass at least 20 to 25 times greater than that of our sun. The sun simply lacks the necessary mass to undergo the catastrophic gravitational collapse required to form a black hole. Instead, the sun's fate is to become a white dwarf, slowly cooling over billions of years. This process will take place over an incredibly long period, transforming our sun into a faint, cooling remnant of its former self. Black holes are fascinating cosmic phenomena, formed from the remnants of massive stars that have exhausted their nuclear fuel and undergone a supernova explosion. They possess an immense gravitational pull, so strong that not even light can escape their grasp. While our sun won't share this fate, black holes play a crucial role in the universe, influencing the formation and evolution of galaxies and providing insights into the laws of physics. They also generate gravitational waves when they merge, which scientists can detect and study to learn more about the universe. As a white dwarf, the sun will continue to emit light and heat, but it will gradually fade over billions of years, becoming a cold, dark object known as a black dwarf. This transformation is a slow and inevitable process. Although this process takes far longer than the current age of the universe, it marks the sun's ultimate destiny, a quiet end to a star that once burned so brightly, leaving behind a legacy of light and warmth. While the distant future of the sun may seem daunting, it's essential to remember that we still have billions of years of sunlight left to enjoy. The sun's life cycle offers us valuable lessons about the nature of stars and the universe itself. As we continue to study our sun and other stars, we gain a deeper understanding of the cosmos and our place within it. The sun's journey is a reminder of the incredible processes that govern our universe. Thank you for joining us on this journey through the life of our sun. We hope you continue to explore the wonders of the cosmos with us.